Good afternoon, students. Today's topic of discussion is factors affecting the resistance of a conductor. So here, the electrical resistance of a conductor depends on some factors. So here, first factor is length of the conductor. So effect of length of the conductor. So how uh, resistance depends on the length of the conductor. So it has been found by experiment that on increasing the length of a wire, its resistance increases, and on decreasing the length of the wire, its resistance decreases. So actually, the resistance of a conductor is directly proportional to its length. That means, as the length of the conductor increases, resistance also increases, and if length of the conductor decreases, then resistance is also decreases. That means resistance of a conductor is directly proportional to its length. That means resistance R is directly proportional to L, where L is the length of the conductor. So here resistance of a wire is directly proportional to its length. Therefore, when the length of the wire is doubled, then resistance also get doubled, and if the length of the wire is half, then resistance also get halved. So next factor is area of cross section. So effect of area of cross section of a conductor. So it has been found by experiment that resistance of a conductor is inversely proportional to its area of cross sections. That means as the area of cross section increases, resistance of a conductor decreases. So resistance R is inversely proportional to area of cross sections. So since resistance of a wire is inversely proportional to its area of cross section, therefore when the area of cross section of a wire is doubled, its resistance get halved, and if the area of cross section of a wire is halved, then its resistance will get doubled. That means if area of cross section double, then resistance will be halved, and if resistance will be double, then area of cross section will be halved. This means that a thick wire has a less resistance and a thin wire has a more resistance. So why? Because a thick wire have a large area of cross section, and that's why it has less resistance, and a thin wire has less area of cross section, and that's why it has more resistance. And also short length of a thick wire is used for, and that's why short length of a thick wire is used for getting low resistance, and long length of a thin wire is used for getting high resistance, and that's why resistor wires are thin. So thickness of a wire is usually represented by its diameter, and that's why the resistance of a wire is inversely proportional to the square of its diameter. And thus when the diameter of a wire is double, its resistance become 1/4, and if diameter of the wire is half, then resistance become 4 times. So let's move on to the next effect. Next one is nature of the materials of the conductor. So electrical resistance of a conductor depends on the nature of the material of which it is made. So some materials have low resistance, whereas others have high resistance. For example, if we take two similar wires having equal length and diameters, one is of copper and another is of nichrome alloy, so we will find that the resistance of nichrome wire about 60 times more than that of the copper wire. So it shows that resistance of a conductor depends on the nature of the materials of the conductor. And last effect is of temperature. So effect of temperature. So resistance of all pure metals increases on raising the temperature and decreases on lowering the temperature. So resistance increases on increasing temperature and decreases on lowering the temperature. But the resistance of alloys like manganese, constantan, nichrome is almost unaffected by the temperature. So next point is resistivity. So we have already discussed that resistance of a conductor is directly proportional to its length, and that is resistance is denoted by R. So R is directly proportional to L, where L is the length of a conductor. Let this one is equation 1. And also we have already discussed that resistance of a given conductor is inversely proportional to its area of cross section, where R is inversely proportional to A, where A is the area of cross section. So by combining equation 1 and 2, we will get R is directly proportional to L, inversely proportional to A. So that means R equal to rho L by A, where rho is the resistivity of the material of the conductor. So here rho is a constant, and which is called the resistivity of the material of the conductor. So from equation 3, so it is clear that for a given conductor having a specific length L and area of cross section A, the resistance R is directly proportional to its resistivity rho. So if we change the material of a conductor to one whose resistivity is 2 times, then resistance will also become 2 times. And if we change the material of a conductor to one whose resistivity is 3 times, then resistance will also become 3 times. So if we rearrange equation 3, then we will get resistivity rho equal to R into A divided by L, where R is the resistivity of the conductor, A is the area of cross section, and L is the length of the conductor. So this formula is used for calculating the resistivity of a material of a conductor, and it should be memorized because it will be used to solve numerical problems. So resistivity and also if a conductor having a unit area of cross section, that unit means 1 meter square. If a resistance has a unit area of cross section of 1 meter square and a unit length of 1 meter, so that means A equal to 1, L equal to 1, then resistivity rho equal to R. And also resistivity of a substance is numerically equal to the resistance of a rod, that substance which is 1 meter long and 1 square meter in cross section, and the SI unit of resistivity is ohm meter. And resistivity of a substance does not depend on its length or thickness. So this one is an important point, that resistivity of a substance does not depend on its length of a thickness. So resistivity rho equal to R into A divided by L. That means resistivity depends on area, resistance and length of a conductor, which does not depend the nature of the substance and temperature. So resistivity of a substance is the characteristic property. So we can use resistivity values to compare the resistance of 2 or more substances. So one more point to be noted, that just as when we talk the resistance in the context of electricity, so it actually means electrical resistance. So in the same way, when we talk the resistivity, it actually means electrical resistivity. So there is a numerical. So a copper wire of length 2 meter and the area of cross section 1.7 into 10 to the power minus 6 meter square has a resistance of 2 into 10 to the power minus 2 ohms. So calculate the resistivity of the copper. So here length of the wire and area of cross section and resistance is given, and we have to find out the resistivity of the material. So here material is copper. So given A equal to, A means area of cross section, so A equal to 1.7 into 10 to the power minus 6 meter square, and resistance R equal to 2 into 10 to the power minus 2 ohms, and the length of the wire is equal to 2 meter. So we know that resistivity rho equal to R into A by L. So by putting the value of R, A and L, we got 1.7 into 10 to the power minus 8, and we know that SI unit of resistivity is ohm meter. So resistivity of copper is 1.7 into 10 to the power minus 8 ohm meter. So there is an homework for you. A 6 ohm resistance wire is doubled up by folding. Calculate the new resistance of the wire. So next point is resistance in series. Resistance or resistors in series. So the combined resistance or resultant resistance means total of a number of resistance or resistors connected in series is calculated by using the law of combination of resistance in series. So what is the law of combination of resistance in series? So this one is that law of combination of resistance in series is that the combined resistance of any number of resistance connected in series is equal to the sum of the individual resistance. That means if the resultant resistance is capital R and individual resistance are R1, R2, R3, R4 and that's it, that means resultant resistance R is equal to R1 plus R2 plus R3 plus R4 etc. So in this way, if some individual resistance are connected in series, then the resultant resistance of the series will be equal to the sum of the individual resistance. So okay, next part will be discussed in the next video. Thank you, and do the homework and send it to me to my personal WhatsApp number. Thank you.